Okay, so I'm going to assume you can do 20 on your own. Number 21. I'm just going to tell you how you would set up 21. For 21, they give you 3 points that create a triangle. And you're trying to decide if this is a right triangle or not. So what you do is you have to find some angles. Or, I mean, that's one way you could do it. You could say, all right, let me try and find the angles and try and see if one of them is 90. You could also create vectors, right? If this is a right triangle, at least one of these is 90. If this is 90, then these two vectors are orthogonal. So if you create this vector, and dot them and get 0, you know you have a right triangle. So let's say you create two vectors, you dot them, you don't get 0. Then what you do is you would take two more vectors, this one and this one, to try and figure out this angle, dot those two together, see if you get 0. If you don't, then you still don't have a right triangle. And then you would take this vector and dot those and hope to get 0. So that's probably the cleanest, fastest way to do the problem, is just to do this combination of figuring out vectors, dotting them, and looking to see if you get 0. If you never get 0, it's not a right triangle. All right, so let's look at 22. 22 is a little more involved. So it says find the values of x such that the angle between these vectors, 2, 1, negative 1, and the vector 1, x, 0 is 45 degrees. Okay, so they want to know if I make this, if I give you a value of x here, like let's say 5, then will the angle between them be 45 degrees? And we need to figure out all values of x that would make the angle between these 45 degrees. So it's kind of interesting. If you look at it three-dimensionally, you have a vector sitting out here. This one's not moving. It's right there. This vector has some certain conditions. The x component is 1, the y component is 0, and the z component is free to be whatever we want. So maybe there's a way that we can find some vectors that'll always make an angle of 45 degrees with this vector. And so which ones do it? So what does it mean for it to be 45 degrees? Well, several ways we could look at this. We know this formula, A dot B must equal magnitude of A times magnitude of B, cosine of the angle between the vectors. We know that equation. We call this vector A, we call this vector B. What would A dot B turn out to be? So if I multiply or dot product these two, 2 times 1 is 2, plus 1 times x, which is x, negative 1 times 0 is 0. So the left side of that equation would be that. All right, the magnitude of A I could figure out. So square this is 4, square that's 1, square that's 1. So I'm doing 4 plus 1, that's 6, and then take the square root. So I have root 6. And then the magnitude of B, so square that 1, square that x squared, square that 0. So I have 1 plus x squared underneath the square root. And then cosine of 45, I multiply, because I need it to be 45 degrees, cosine of 45 degrees will be root 2 over 2. So this is an equation that has the variable x in it. So let's clean it up a little bit. Okay, the left side is just 2 plus x. I'll just put x plus 2 instead. Equals, over here, how should we do this? Let's go ahead and trying to figure out how I want to mess with these roots. How about we put the root 2 times root 6, make it root 12. So I have root 12 over, there's a 2 here, 2. And then this, which is root 1 plus x squared, like that. So that's the right side. And I need to try and solve this for x. So when I solve this for x, what I'll do is I'll try and free this x squared from the radical. So I'm going to square both sides of the equation at this point. Square this side, square that side. I'll get over here x squared plus 4x plus 4. So just multiply that out. And then over here, when I square, since it's multiplication, I square this and then square this. So I get 12 over 4, which is 3, right? Square top 12, square the bottom is 4. And then I square this square root, I get 1 plus x squared. And what I'll do is I'll distribute the 3 through now. I have a quadratic equation. So I'm going to bring everything to one side. So I'm going to make this side 0. I'm going to have 3x squared, but I'm going to take an x squared away, so 2x squared. I'm going to bring the 4x over, so negative 4x. And then I'm going to subtract 4 on both sides, so minus 1. And then from there, I'm going to use a quadratic formula. Okay, so when I use a quadratic formula on this, it's not going to factor. I get x is equal to negative b, which is 4, plus or minus the square root of b squared, which is 16, minus 4 times a, which is 2, times c, which is negative 1, all over 2 times a, which is 2. So that's our quadratic formula. And we should get, hopefully, a couple answers here. 4 plus or minus the square root of, let's see, this is going to be 8, negative 8, but we're subtracting, so plus 16 plus 8, that's going to be 24, all over 4. And what can I do here? I can pull out a 2 out of there, right? So this is 6 times 4, so square root of 4 comes out as a 2, root 6, all over 4. And so I get, reduce everything by a factor of 2. We get 2 plus or minus root 6 over 2. And that's 2 potential answers. Now I need to check these. The reason I need to check them is because it could be possible that I have an extraneous solution because I squared, and anytime you square an equation, you could potentially introduce a solution that doesn't work. So what I would need to do to check this is I need to take the vector, the original vector, which was 2, 1, negative 1. That's my A. And then my B is the vector 1 and then x, which I just found to be 2 plus or minus root 6 over 2. And then 0. This is B. And I need to check that the angle between those is 45. So I'd have to check both the positive and the negative case. So let's just take the positive case, and I'll let you check the negative on your own. What's the angle between those vectors? Well, the angle between those vectors is the inverse cosine of A dot B. So let me try and do A dot B quickly. 2 times 1 is 2, plus 1 times this. So 2 plus root 6 over 2. That's A dot B over the magnitude of A. So the magnitude of this is this squared, 4 plus 1 plus 1. So that was root 6. The magnitude of this one, which is that squared, this squared, 1, plus, now we have to square this, and that's going to be a little tricky. I know the bottom of it is 4. The top of it, though, is this squared. 2 plus root 6 times 2 plus root 6, which is 4 plus 4 root 6 plus 6, which is 10 plus 4 root 6. So we could put that in there. That's going to be just the top. So this is 10 plus 4 root 6. and then plus this 1 squared, which is 0. So this is kind of an ugly number here. 1 plus 10 plus 4 root 6 over 4. And so I need to get my calculator out and I need to do that. Am I going to do it? Do I feel like doing it? I'm using my phone. If I had my calculator, I'd feel better about this. Using the phone to do it's a little harder. Let me try it. Okay, I'm going to do 6 root plus 2 divided by 2 plus 2. So this whole top here, I'm getting 4.2247 over, now let me try and do this. 6 root times 4 plus 10 divided by 4 plus 1 square root times 6 root. I'm getting 5.974, something like that. And I'm going to take cosine inverse of this. So let me try that. 4.2247 divided by 5.974. And then arc cosine. Oops. Times 180 divided by pi. I'm getting approximately 44.9939 degrees. Close enough. So there's some rounding error in there. So it did work. So using a plus here worked. You would have to check to see if the minus works. It also works. I'm not going to show it. So interesting problem. 23.